Hi everyone, welcome to my talk on making Shiny app deployments easier. So I want you to imagine you're a data scientist, or many of you probably don't have to imagine. You've got a great idea for a Shiny app, and you're like, right, okay, let's go ahead and make it. So you spend a bunch of time creating your app on your development machine. You might spend some days, weeks, maybe even months. And 100 cups of coffee later, you've got the finished product, which is a valuable Shiny app. Something that's super useful, something that might be used in a business context. So you have your valuable app. It runs super smooth on your machine locally. It's a testament to all the hard work that you've put in. But now comes a time when you want to gift your creation to a wider audience. And that means thinking about deployment. It's great that it works on your machine, but now you need to share it with people other than yourself, and that means thinking about servers and IT and platforms and things like that. So if you're using Posit Connect, it's got a nice, easy workflow for deploying and managing apps. It's got a great user interface. It's got this smooth, one-click deploy function. The thing is, someone has to maintain this platform. If you don't want to maintain the platform, shinyapps.io is a very similar workflow. It's maintained by Posit. You don't have to worry about keeping the underlying system updated, but it has costs. Some, for more intensive apps, maybe your project has restrictions on data residency, as the servers are in the US. Maybe you're a developer and you don't care about any of this stuff. You might be in a company where you give your code to another team and then they look after the deployment, and they might come up with some sort of solution using the open source Shiny server or Shiny proxy. There's a whole bunch of ways to deploy a Shiny app, but whatever deployment method you've gone with, on the journey of making this app, there's a bunch of hurdles that you've had to jump over, and I guess the final hurdle is deployment. So it'd be a real shame if you fell at the final hurdle and your app fails to deploy. I know they're not the same picture, but hey ho. So what can we do to help avoid this? Here's this question. I like to think that there's two personas involved in the deployment process. Now, these personas could be separate people, it could be two separate teams, it could be the same person who sees through the whole process. They develop the app and then they deploy it themselves and figure out all this, server stuff. The first persona is the developer. They're individuals that write code to create applications. They work on functionality, user interface, features. The other persona in the process is IT operations. So the people who are responsible for setting up, deploying and maintaining applications on servers, and they ensure that it's properly configured, it's available, and hosted somewhere. It's possible that this persona could be looking after more than just Shiny apps. They could be looking after a whole host of internal infrastructure, or they might be maintaining a platform that Shiny apps are deployed to, like Posit Connect. So a little bit about me. I'm someone who fits into this IT operations persona. I'm not much of a Shiny developer. I don't develop Shiny day to day. You might be thinking, why am I giving a talk here? But I guess I know enough to maybe make a silly cat app. I'm in this IT operations persona because of my role at Jumping Rivers. Been with them coming up to maybe 3 years now. We offer all sorts of services related to the data science field. We offer training in R and Python, Stan, Git, Scala, all sorts of stuff. I don't actually do any of that. The things that I listed there, I probably do maybe these three things. In particular, manage Posit products and infrastructure. And that's a service where we aim to take the pain of creating and managing cloud infrastructure and data science tools, and allow data scientists to get on with data science problems rather than server sysadmin type problems. So I provide support to customers who use those platforms through email and sometimes video calls and things like that. So people that use these platforms make Shiny apps, and sometimes they don't deploy or work. So I sometimes get queries from clients along the lines of this. Obviously, they give a bit more context and preamble, but it boils down to this problem of, my app works on my machine, but doesn't work when deployed. Can you help out? So this talk is aimed to touch on some of the sort of causes for deployment failures that's in that role. So how do you know when a car is having problems? Well, if you turn the ignition and it doesn't start, that's probably a pretty good indicator. You might see some warning lights on your dashboard. That's usually a sign that something's wrong. If you have a bit of know-how, there are a bunch of things you might check under the hood of your car. I wouldn't know what that would be, but I assume that's the thing. So if your Shiny app isn't deploying, you might check your logs. But these sort of logs, not those logs. The deployment logs sort of give us a peek under the hood of our deployment, and it might reveal some information about its behavior. So you find deployment logs in different places for different platforms and different methods of deployment. It's the first port call when you're troubleshooting apps. So in our Studio Connect, Posit Connect, it's this tab in the top right corner. There's this handy logs tab in shineapps.io, and sometimes you might need access to the actual server that it's hosted on, and it will be in the var log directory if you haven't changed the config or something like that. So just like looking under the hood of a car for the first time, looking at logs might be a little bit intimidating at first. They contain a lot of text, but there's often keywords and telltale signs, and if you look at them all the time, then there's keywords that you'll pick up and learn about. A common pitfall that's stems from hard-coded variables or hard-coded secrets. Now they're not great from a security perspective, especially if you're putting code into a Git repository or something like that. I'm going to assume that you all know what Git is, but if you don't, feel free to grab me afterwards and I can try and explain. So this is an example database connection with some credentials that might be used for developing locally. You have a Postgres connection with a database name, host name, port, username, password. And this might be what's actually required when you actually deploy. You want to put these into a Git repository, and if you didn't want to do that, you need to remember to remove the sensitive values and add them back in when you commit into your Git repo. The code then isn't consistent with your source control, and it's an extra step that can sometimes be forgotten. So that's something that's happened with a client previously. While this is bad and involves some extra effort, if you remember to do all this, it doesn't necessarily cause a deployment to fail, but if you do forget, then that can be, incorrect credentials is a cause. So anything that could be done to make this more simple would be helpful. So what you can do is add in replace variables with calls to environment variables. Now this could be committed to a Git repository. It doesn't have any sensitive values in, and the code's the same between dev and prod. So awesome. What was I going to say? You just have to set the environment variables in the environment. So you might be thinking, where do I do that? Here's Posit Connect. It's a bit small, but the section I want to draw your attention to is on the right-hand side. There's this variables tab, and there's this section for setting environment variables. We've got the names of our environment variables from the code before. And if you click edit, you can only set a new variable. It doesn't show the old one. And it means that these variables are stored securely from other users of the platform. So this is particularly good for things like personal API keys and things like that. Database credentials. With platforms like shineapps.io and Shiny Server, you don't have that. It's not quite Swish, but you have this renv file in your app directory to set environment variables. This is a file that is ignored in a standard R git ignore, so that also wouldn't be committed to a repository. So getting credentials wrong sort of more leads to this real problem that I want to talk about, which is the availability of external resources. So just as cars need fuel to run, your app probably needs, likely relies on data to run. Your app might rely on APIs that allow external systems to communicate and interact with your app. You might pull some data from a database to populate your nice visualizations or whatever it is that you data scientists do. Similarly, you might pull resources from a remote file. If these resources aren't available, then your app's field source isn't available. And common causes for this are things like incorrect credentials, which I've covered, connectivity. So I know that with shinyapps.io, in order to access a database that's behind a firewall, you'd have to whitelist some shinyapps.io addresses in the firewall, and you'd have to ask an admin or whoever's in charge of that. Another thing I've seen is permissions of the user in the database. So you want to ensure that your database user specified in your Shiny application has the necessary permissions to perform the operations. So if the user might be a read-only user, and if you're trying to do a write operation, then obviously that's not going to work. The next reason apps fail to deploy is probably the most common, and it's issues with dependencies. So the libraries and packages and files that make up your app. So just as there's a bunch of parts that fit together to make up a car, it's crucial to ensure that you have a clear understanding of the dependencies of your app. Think about maintaining a detailed car parts list or instructions to build a car. If something's missing from that list, then you're not going to be able to build the car. The Iris Connect package and like write manifest function can be really helpful with maintaining things like this. That's great for our package dependencies and files. But it can't really help when it relies on sort of underlying system dependencies and you don't have permission to install these yourself. So things like this could be like C and C++ development tools. So many R packages, as you probably all know, contain code written in C and C++ for performance reasons. And if you use these, you need to have these installed. Certain packages might need system utilities such as wget, git, or curl to download data or interact with external resources. If you plan to use R packages for generating documents with LaTeX, you need to have a tech distribution installed. Quarto seems to be all the rage nowadays. I'd love to know how to use it, but my role doesn't really extend to much more than installing it currently. I think I've drilled home this obvious point that if a dependency isn't there, then that's probably the reason your app doesn't work. Another consideration is that you need to, the resources that are available in the environment in which your app is deployed. So just as a Formula 1 car needs a suitable engine to perform well in a race, if the car doesn't have a suitable engine, then it's probably not going to do as well as the other cars in the race. I'm trying to keep up this sort of car analogy thing going on, but it's not getting so great. Shiny app requires appropriate computing power and memory to operate effectively. And a lack of resources could lead to sluggish performance, and it could break if it runs out of memory. Rather than increasing the resources on the environment, you can come at it from the other end and sort of make code use less resources, just like how you tune a car's engine to run optimally. As a developer, you can tune your app's code to use fewer operations, CPU cycles, memory. Here's a book that Colin wrote. It'd be a complete lie if I said I'd read it. But the title sounds relevant to this bullet point, so I just thought I'd throw that in there. Sometimes there's platform configuration settings related to resources. So there's this max app image size config in the Connect config. And if your application uses large assets like images and data files and dependencies, and the total size of these assets exceeds this limit, then that's something we've come across before. And it could be the configuration settings of the platform that are stopping your deployment. So now I'm going to touch on some proactive approaches you can take rather than just focusing on issues. So one effective approach is continuous integration and continuous deployment. So that involves the process of automating the process of integrating code changes and automating deployment. And it involves creating, like a bunch of rules and check steps for events to happen before integrating your code back into a code base. And like the idea here is that like with any automation, it's going to save you time. So it's a pretty broad topic that isn't just limited to Shiny, and you can kind of go as far with it as you want. Yeah, imagine we're in Git and we have a main branch that we're wanting to keep clean, and we want to add something new in. We don't want to push straight to the main branch, and at JR we have this main branch protected. So if you try and push the main branch, it gets sad. So what we have to do is we have to make a development branch. We make some changes in this branch, but we want to check some things before integrating it back into the main branch to check that it meets our standards. So this is where CI comes in. It's like a set of jobs that run on a CI runner, which is like a special program on a computer, like in the cloud, or like could be a physical machine, and it's likely like linked to the Git repo. The idea here is that there's a pipeline of jobs that will run on a trigger. So something like a code push or a commit would trigger this set of tasks in motion. Here are some things that you could do in a CI pipeline, like check that your Shiny app runs. It could also be used for like R packages and like check that your quarter dot compiles. Something that we also do in the company is linting. Colin is very sad when it comes to poorly linted codes, but he's happy when it's nice and linted with linter. So yeah, now that Colin's happy and all the code is linted and the app runs, the code can be integrated back into the main branch. Another thing I'll touch on is containerization. So that involves packaging up your app and its dependencies and like any sort of environment variables and things like that into these isolated environments known as containers. So a tool that's used for this is Docker, and the idea is that you can run a Docker container on any machine that has Docker installed. This ensures consistent behavior across different environments because it's the same environment across different machines. It's like encapsulating your car's engine so that it works the same way, no matter in which car it's placed. I know that's not really a thing, but obviously just trying to keep up this car analogy thing going on. Monitoring and alerting systems can play a pivotal role in catching issues before they escalate. So just as modern cars come equipped with sensors that alert you to potential problems, your Shiny app can benefit from monitoring tools that notify you of performance anomalies, resource usage spikes and errors. So setting up alerts can help you take like proactive action and try and prevent downtime and ensure a smooth user experience. So key takeaways. I was going to put a silly slide in here about like going to the chippy or something like that. So logs will give you good clues about what's going wrong. Knowing where to find them is good knowledge to have. I went into hard-coded secrets, but basically a lot of the problems are like dependencies and things being available, whether they're external dependencies or like internal ones. That's my talk. Thanks for listening, guys.